Okay, so hi everyone. This is Ifran Dilip, third year electronics engineering student at ZHCET. And
hi everyone, this is Zaid Hussain, a third year electronics student at ZHCET too. So we are today's presenters for this session.
Okay, so we will be taking you to a walkthrough session for Arduino, and this is going to be a very interactive session. So if you're comfortable in opening up your videos, it would be really great. And if you have any questions, you can just put them up in the chat box. We will be taking them at the end of the session, or we can take it in between, whatever you like. And if you want to ask anything in between, you can just unmute your mic and speak. Okay. So before starting, since this is an Arduino session, I wanted to know how many of you are from electronics. Yeah, apart from me and Zaid, obviously. So if you can just raise your hands or just write in the chat box, or you can just tell us about if you know anything about it, or if you are a beginner, or okay, is
there a Kahoot quiz?
Is there a Kahoot quiz on current session?
There is not a Kahoot quiz on this current session. There will be a project given to you at the end of the session. So please stay tuned.
Okay. So without further ado, let's get started with our session.
Electronics.
Okay, we have somebody from electronics. Great. So people from electronics, if you know anything about embedded systems, or when you hear the word embedded system, and from other branches as well, when you hear the word embedded systems, what comes to your mind, or anything you know about embedded systems?
You guys can open your mics if you're comfortable.
Yeah, or just type it in the chat box. Echo. Okay. Okay, great. You're from civil. Okay. Let us tell you more about embedded systems.
It is the linkage of software and
hardware. Okay. So, yeah, you are a little correct. I would just tell you about the basics of it. So anything from a small Nokia mobile that you might have used to a big washing machine or the refrigerator in your house can be considered as an embedded system. Okay, because it contains both a hardware system and a software system, which is like the integration of hardware and software, right? So you can give them instructions, and the system can work on your instructions or perform several tasks that you ask the system to do. Okay, before starting the session, I would like to know if you want the session to be purely in English or Hindi, or do you want me to go us to go hybrid? Okay, this you can very clearly write it in the chat box. Okay, mix. Great. We can go mix then. Okay, nice. Pure Hindi. Okay, we can try. We can go mix because it's 50-50. Great. So I hope you got the term embedded systems. So embedded systems, दो चीज का बना होता है. One is the hardware part. The other is the software part. It is basically the integration, which is the combination of both of them. Okay. And coming from embedded systems, have you heard of this term called microcontroller? क्या कभी सुना है microcontroller या microprocessor, something like that? कभी भी सुना हो अगर किसी ने microcontroller या microprocessor? Yeah, great. We have a response from Aisha, Uzma. Okay, great guys. So anyone who would like to tell us what do they understand by the word microcontroller or microprocessor? Anyone or both of them? Suna hai. Okay.
A compact integrated circuit designed to govern a specific operation.
Sorry?
A compact integrated circuit that governs some specific information operations.
Else? I didn't hear. Okay, so great. I think we have a response from Shanur. Okay, so microcontroller and what do you think? Microcontroller and microprocessor, are they same or are they different? Microprocessor is a computer processor. Okay. Where the data processing logic and control is included on a single. Okay, that's nice. They are different. Okay, Aisha, they are different. Definitely, they are different. Okay, great. So I think you guys know that they are different, definitely. So microcontroller is like a mini computer in itself. It has got memory, it has got output devices, and it is all of it is connected internally. While when we talk about microprocessor, it also has memory and input-output devices, but it is connected externally, right? Like you can take example of some hard disks that you use to transfer information from your hard disk to the laptop or your computer or a pen drive. So a computer acts as a microprocessor here, right? But when we come to Arduino, which is basically the most popular microcontroller that we have heard of, it is a microcontroller, right? You can also see in the presentation that we are presenting, it has a USB port. It also has another port where you can just connect the devices, and it also has an IC which is known as Atmega 328, and so this is Arduino, and we will be talking mostly about Arduino Uno, which is the most popularly used. And can anybody just tell me, it's like a fun fact, can anybody tell me why is it called Arduino Uno or Arduino Uno? Anyone who knows it? What does the word Uno means or Uno means? It's like a very fun thing to know.
The Uno means one in the Italian language, and so it was named to the initial release of the software.
Yes. Anyone else? Okay, so let me tell you a fun fact. So Uno means one, okay? So Arduino Uno was basically launched after an year when the Arduino company was formed. So it is like the celebration of the birthday of the company Arduino. So that's why we call it Arduino Uno. We also have some more microcontrollers from the company Arduino, which are also known as Arduino Nano, Arduino Pico, Arduino Yun, Mega, and etc. So this is the story behind it. So let me tell you more about the pins that we have in Arduino. Can anybody guess, like, do we have same pins, or do we have analog pins or digital pins? Anyone? And how many are there? Have you guys ever seen an Arduino? There's Arduino.
14 digital pins.
Okay, so I think this is the camera. So this is the Arduino board that we are showing. I think it's here. Okay, great. Okay, this is the Arduino board, and you can also see in the presentation that we are presenting,
14 digital pins.
it has okay, 14 digital pins. Great. Okay, it has 14 digital pins. You're absolutely correct, Sanu. And it also has 6 PWM. PWM we'll be telling you like when we go on with the flow. And we also have analog pins. Can anybody guess or just count them from the diagram? How many analog pins are there?
5
It's
analog.
there, guys, in front of you.
6 analog pins.
Okay. Somebody's saying 7. Somebody's saying 71. Okay, I think it's okay. 6. Great. Oh, you got it, Chandra. It's 6. You can see from A0 or A0 to A5, we have 6 analog pins, and we have 14 digital pins. Starting from 0 to 13, and we also have some PWM pins, which you can see there, and it has a tilde sign, yeah. And okay, so I also told you about the USB port, and it has different ground pins also. It for power supply, it has a 5-volt supply and a 3.3-volt supply. So that's all about the pins or the Arduino board that you should know. Then moving on to the software part, where we'll be using an IDE called the Arduino Ide, and I would like you guys to just, because it's a hand-on session or a walkthrough session, I want you guys to go with us and download this IDE called the Arduino Ide. We'll be sharing the link in the chat box. You can just go there and download it with us. If you have any problem, just let us know. Or if you already have it installed, then it's perfect. Okay, so we have shared a link in the chat box. You can just go and click on the download option. Are we sharing the screen? So if you already have it, or we can move on, or you can just start downloading, or you just start downloading.
Yeah, first year.
Okay, no, I haven't heard yet.
What about on mobile? You can't download the ID on mobile. We are really sorry.
You can download it in the laptop or the PC that you're using. Okay, just let us know when you are done. Just give us a thumbs up or whatever. We just want you to work with us, that's all. No pressure, or you can just download it later and start working on it.
2.0 version. No, the version 1.0. 1.8. I think we can move forward.
Okay. After downloading, you will see this window, or when you open the IDE, you will see this, and you can clearly see that we have a menu option at the top where Arduino is written. File, edit, sketch options are there. And the fun fact here is that you can go in the file option, and you can also check for the examples which are also given in the IDE. So if you don't know how to start with it, you can just read about the examples and start with it. Okay. You also have the coding area, the area which is the white part, and the terminal at the bottom, the black terminal. And then we can just move on. And yeah. So here you see that the first option is the verify option. So like if you write lots of code, or you know that sometimes we definitely go on miss a semicolon or colon or maybe a bracket or something. So just for checking the code, if you're writing it is correct or not, we can just click on the verify option. If the code goes green, you are good to go, you can go ahead. But if it's red, then you have to check the code. So here what the verify button does, then the upload button. So we are connecting Arduino with the laptop. So you have to upload the code to the Arduino Uno, right? So to upload the code, we have this upload button. Then you can also create a new sheet from this button, and then open an existing one or save your file from this one. Okay. Then, okay. So if you I think most of us do not have an Arduino board at home, but we do have some software that gives us hands-on experience, right? I think there's a question.
Okay, Arduino is in which year in syllabus? Arduino is not in syllabus, it's just an extracurricular thing that you can study.
Yeah, and it's really fun. Okay, so you can just, we are sharing this website called Tinkercad. You can have hands-on experience with Tinkercad. It's very easy to use. You just need to have your Google account or whatever account, and you're good to go. We're sharing the link. Just go on this link. Yeah. When you open this link, we're just like sharing the whole thing. Okay. After downloading, after just logging in, you will see this window. This window will appear, and it has.
You just click on Start Tinkering. Once you open this window, you will be greeted with a sign in which there will be two options. You have to click on Start Tinkering button, and then log in, and then you will be greeted with this dashboard window. Once you plan the session for everyone. Yeah. It's for everyone.
It's for everyone, yeah.
So once you guys are on the dashboard, please tell us, and then we can continue with the session. So you guys should log in.
Okay, when...
Please repeat this procedure.
Okay. What you have to do, you just have to go on the link that we have sent in the chat box. We'll send it again. Okay. Just go on it, log in, and then click on Start Tinkering. Okay? Okay, Start Tinkering. I don't know.
First click on Start Tinkering, and then log in, and then you will be greeted with this dashboard window.
Let us know when you are done logging in.
Done.
Okay, great. Okay, I think most of you are done with it. And if you're not done, you can just follow up. It's very easy. Okay, great. Okay. When you see this, you have 3D design circuits, code blocks. You can just click on circuits part because we'll be creating some circuits, and then click on new, create new circuit. Okay, the green option. Okay. Great. Now you can just type whatever component you need here. For the very first program, we will be writing the blinking of the LED. For that, you will need an LED, an Arduino board definitely. So first, we're taking an Arduino board. You can just type Arduino in the in the search box, and then you can see the Arduino will appear, and you can just resize it by zooming it or unzooming it. Yeah. So here is the board. Great. And you also have the code option where you can just click on text option. Just don't go for blocks, go for text. It will ask you if you are sure, just click on continue, and you can see this window appears. And yeah, great. So we will also be coding the first program. Then, yeah, I guess sharing the screen. Then we will, 1 minute. Okay, then starting with the code. I think everybody got an Arduino board with them for now, definitely, virtually. So for starting with the code, like if you are familiar with C or C programming or any other programming language, you know that there is a function called main. But here in Arduino, we have two functions called a setup and a loop. So a setup function runs once, while loop, as the name suggests, runs again and again. So what we do in setup, since Arduino has pins, right? So we define the pin numbers there in the setup section, and in the loop section, we write the main body of the code or the code that we want. Okay. Then, okay, moving on. I will definitely tell you more about the code part. Then moving on to one of the most important things that we use. So to increase the number of pins, or like to increase the usability of the pins, I can say, we use this breadboard. You can see the breadboard has a plus or a plus and a negative side, a negative sign on it. So the positive side is used to connect the Arduino to the 5-volt supply, or the Arduino to the 5-volt or the 3.3 volt supply, and the negative part connects it to the ground, right? So one important thing here is that the extremes of the board are series vertically, and the middle part of the board is series horizontally. Okay, just to get the uniform current, because we are dealing with circuits and all. So let's start writing the first code. Yeah. So we will be writing a code for blinking of an LED. So for that, we will be using an LED also. Okay. Okay. So let's take up an LED for now. You can search for an LED in the search box. Okay. So for the LED, can anyone tell me like how many terminals are there in the LED, and like which is the positive and which is negative? Okay, we can also take a breadboard because you're using it. Card box. Okay, let me tell you. Then, so the LED has two terminals. One is the positive and the other is the negative. Usually, the longer terminal is the positive and the shorter one is the negative. But here you can see there is no short, there is no long. One part is a little curved, right? So that is the positive part, which is the longer one, and one is straight, which is the negative part. So let us connect the negative part to the ground of the Arduino, right? So we are just connecting the negative to the ground and the positive to the 5-volt supply. Okay. Okay, great. So we are connecting the positive to the pin of the LED that we'll be using. Sorry, not 5 volts. And then we, as you can see, Zahid has connected an LED to the Arduino board, right? How many of you thinks that it's correctly connected? Like whatever I said, he did that. Two terminals. Okay, great. Nice.
Right.
Okay, since we are connecting the LED, I think we have to show them the socket again. How many of you thinks this is correctly connected? The negative is connected to ground and the positive is connected to the pin number 13 of the Arduino board, right?
Is my connection correct or is it wrong?
Okay, if wrong. Okay, koi keh raha hai it's wrong. Great.
Can you just chat in the type box?
Or
Type
just
box.
speak up. This is an interactive session. Okay, I think people got it. So yes, it is wrong, definitely.
Why is it wrong, Ifra?
Okay, so let me tell you why it is wrong. When we are connecting the LED directly to the Arduino, we are actually trying to blow up this LED, right? We are actually fusing the LED by directly connecting it to the board. So just to like control the amount of current that it would be provided and all of that, we can use something that starts with an R. What do you guys think? We can use a device to writing it. Okay,
resistor.
great. Samir got it. We will be using a resistor to control the amount of current. PDF. Okay. So अब हमें resistor.
But Ekra, what is the value of the resistor that we have to connect?
Okay. हम सबको पता है कि बहुत सारे बहुत सारे क्या बोलते हैं उसको values of resistors present हैं. तो हम कौन से value resistor की use करें कि हमारा LED blow up ना हो, fuse ना हो, basically. So हम क्या करते हैं? We use this simple formula. I think हम सबने पढ़ा है इसको. V is equals to IR, right? So R is equals to V upon I. V is the voltage और V को हम ऐसे represent कर सकते हैं कि V of the Arduino minus V of the LED upon I of the Arduino, right? So V of the Arduino हमने अभी देखा था, which is 5 volt, and V of the LED that we are using, अभी जो हम use case use कर रहे हैं यहाँ पे, वो है 2.2 volts now.
But you can select the V of the LED using its data sheet.
Yeah.
Which is available in the internet.
Okay. और I भी जो होता है Arduino का, which is basically 40 milliamperes, yeah. So जब हम resistance इसका find करते हैं with the formula, so we get an approx value of 170 ohm. Okay. So 170 ohm का resistor क्योंकि market में present नहीं है, तो हम उसकी closer value ले लेते हैं जो कि available है market में. Okay. So यहाँ पे हम use कर रहे हैं अपना 200 ohm का resistor. Okay. We can, yeah, in Tinkercad you have this option to change the value. Okay.
Then we will be connecting.
So, yeah, we will be connecting it to the Arduino. Okay, I hope it's done. Okay, so all our connections are done for now. सारे connections हमने कर लिए, resistance भी हमने ढूंढ लिया, LED को connect कर दिया Arduino से, Arduino की pin number 13 से connect किया है हमने यहाँ पे. अब we can start with the code part. So Tinkercad में you can write और कोई मुझे बता सकते हैं अब void setup में हम क्या define करते हैं? अभी I have told you guys. Void setup में हम क्या लिखेंगे अपने कोड के हिसाब से?
Pin mode.
About the pin.
Pins define.
Great, nice. Pin mode. Okay, nice. So in the setup part, हम यहाँ पे pin mode को initialize करते हैं अपने. So moving on. So pin mode को कैसे define करते हैं? Pins can be defined as pin mode और pin mode के अंदर दो parameters आते हैं. One is the pin number. Here we have used 13. तो हम जहाँ पे लिखा है LED built in, उसकी जगह हम 13 यूज कर सकते हैं. और क्योंकि LED से हम एक आउटपुट चाहते हैं कि LED ब्लो हो या नहीं हो, तो हम क्या करेंगे? आउटपुट वहां लिखेंगे. ओके, यहाँ पे हम फर्दर केसेस में इनपुट भी एक जगह लिखेंगे, तो वो आपको पता चल जाएगा. सो हम यहाँ पे अभी लिख रहे हैं अपना आउटपुट. सो यहाँ पे हमारा डिफाइन हो गया. ओके, राइट. ओके, पिन मोड में वी आर राइटिंग इट. देन ओके, okay, great. Now you can also code with us if you want. Then हम आते हैं अपना पिन मोड हमारा हो गया. देन आते हैं हमारा हाई और लो की बात आती है. तो हमारे आउटपुट में या तो हमारी, क्योंकि हमने डिजिटल पिन यूज किया, तो यहाँ तो हमारा LED ग्लो करेगा या नहीं करेगा, राइट? तो हम इसको 1 वैल्यू दे सकते हैं या 0. 1 इज द ऑन एंड 0 इज ऑफ. देन हम आते हैं अपना void लूप पे. void लूप पे हम बेसिकली अपना पूरा फंक्शन लिखेंगे. सो हम void लूप को कैसे लिखते हैं? सबसे पहले हम यहाँ पे, क्योंकि हमने एक डिजिटल पिन यूज की है, सो वी आर राइटिंग डिजिटल राइट. ओके, वी आर एक्चुअली गिविंग द वैल्यू टू दी LED पिन. ओके, सो यहाँ पे डिजिटल राइट के अंदर भी हमारे दो पैरामीटर्स आते हैं. वन इज द LED पिन दैट वी हैव यूज्ड 13 अगेन, एंड देन वी कैन राइट हाई. क्योंकि हमें LED ब्लिंक करनी है, तो एक बार हमें हाई चाहिए और एक बार हमें उसको लो चाहिए. सो आउटपुट का आई हैव ऑलरेडी टोल्ड यू, तो हम हाई लिख देंगे वहां पे. देन वी आर ऑल्सो गिविंग डिले. डिले मीन्स होल्ड करना किसी चीज को. देन डिले की जो वैल्यू होती है अंदर, वो हमेशा मिली सेकेंड में होती है. तो आप लोग ये याद रखें कि डिले के अंदर जो वैल्यू पास करते हैं, हम मिली सेकेंड में पास कर रहे हैं. देन अगेन हम क्योंकि ब्लिंक कर रहे हैं, तो एक बार हमें हाई चाहिए, एक बार हमें लो चाहिए. सो अगेन वी आर राइटिंग LED built in, which is the pin number again, और वहां पे हम low भी लिखेंगे क्योंकि उसके बाद हमें बंद करनी है LED को. So, okay, you're writing it? Great. So we are writing digital, right? LED 13. LED का पिन नंबर 13 and high दे रहे हैं हम उसे. फिर delay हम कुछ भी दे सकते हैं, even 5 milliseconds or 1000. Okay. Okay, then हम उसको low देते हैं. So ये हो गया हमारा first program, which is the LED built-in. और जो भी हमारे साथ कर रहा है, they can definitely write their queries in the chat box. Okay. Then अब यहाँ पे हमारे पास Tinkercad में एक ऑप्शन होता है start simulation का, so we can click on it to just check कि हमारा फंक्शन हमारा प्रोग्राम काम कर रहा है या नहीं. So let's start simulation. Okay, you can click on. Okay, so you can see the LED glows and then stops to glow. So the function, so the program works. Congratulations, you have written your first program here with us. Then, okay. Then moving on to the next part. What if we can actually control this LED, like where to? Okay, so anyone who just wrote the code with us here, anyone जिसने अपना अभी हमारे साथ काम किया और उसका काम चला using Tinkercad?
Yes.
Okay, that's really nice. Great work, guys. Okay, so now moving on, let me ask you, what if we can control this part? अभी तो हम कोड के हिसाब से दे रहे थे, उसको डिले दे रहे थे और हाई और लो कर रहे थे. What if we can control it like in your houses? You have fans, you have tube lights and all of that. You can control it using what? Anyone?
You can write in the chat box.
Sensors, great. Okay, but think about real life examples. Like अभी अगर मुझे ये लाइट बंद करनी है अपने यहाँ की, तो क्या करूँगी मैं? Switches. Great guys. So let's modify our code by using a switch. So Zaid will be telling you more about the switch part.
Okay, so the switch that you can see on the screen is called as a push button switch, right? So इस push button switch में 4 terminals होते हैं. You can see here. So जैसे if you're not pressing the button, the circuit will be open like this, and if you push the button, the circuit will be closed and the circuit starts to glow or circuit starts to work, right? तो इसका जो divide होता है बीच में, यहाँ पे एक there is something called divide here. So ये वाले जो circuits हैं, so ये वाला जो circuit है वो ऐसे complete होगा and this will be completed like this. तो आप actually आप दो अलग-अलग devices को एक साथ convert कर सकते हैं using a push button switch.
Okay, so for modifying our code, we can use the push button switch in our code. तो हम again Tinkercad पे जाते हैं and you can modify this code with us. You won't be.
But click on stop simulating first.
Yeah. Just click on stop simulation and then you can start with the switch. So you can type switch.
Push button.
Okay, we are connecting the push button here. Okay, so as I had already told you how to connect the push button to the Arduino, you have to connect one of the pin to the Arduino board pin. And here I think we are using 2. Okay, yeah, we are also using a resistor here. And then we are connecting this to the pin number 2 of Arduino. Okay, and connecting one of this to, okay, great. Now let's move on. The connection is done. Let's move on to the code part.
Take a second.
Okay, now let's move on to the code part. Again, we will be changing a few things with our setup. So, हमने pin mode में अभी हमने pin mode में अभी connect किया था अपना LED वाला button. Now we will be connecting the pin mode to the अपना switch वाला button. तो हमने यहाँ पे 2 दिया है switch को. क्या हुआ?
I think the circuit made here is wrong. Just a second.
Okay, you can just, we will be providing you with the PPT. You can just change it accordingly. Okay. Then we have our pin mode for the switch button, right? So switch button में हमने क्योंकि pin number 2 दिया है, तो आप button pin की जगह pin number 2 लिख दो. और क्योंकि switch क्या होता है हमारा, क्योंकि हम उसे input दे रहे हैं, हम उसे on करते हैं और off करते हैं. So instead of output, we will be writing input there. Okay. Then again, moving on to the loop. So if you are familiar with programming, any one of them, you must know more about the if and else statement, right? If else ऐसे work करता है कि अगर ये नहीं हो सकता तो वो कर दो, right? तो हम if में क्या कर रहे हैं अपना, क्योंकि हमें switch को connect करना है LED से और उसको बंद करना है, खोलना है when we want, तो हम वहाँ पे digital write देंगे क्योंकि हमने digital pin से connect किया था. और बटन स्टेट को हम ऑलरेडी एक वेरिएबल बना लिया अपना बटन स्टेट, जिसमें हम डिजिटल रीड देंगे क्योंकि इस बार हमारा पिन रीड कर रहा है हमारी कमांड को, ना कि राइट कर रहा है. तो डिजिटल रीड में हम बटन पिन देंगे विच इज 2 अगेन. देन इफ स्टेटमेंट में क्या करेंगे, हम लिख देंगे कि बटन स्टेट अगर ऑन है, इफ इट इज हाई, तो पिन पे राइट कर दो, यानी एलईडी पिन विच इज 2 हियर, तो पिन पे हमारा राइट कर देंगे हम पिन पे राइट कर देंगे हाई. और जब हमारा बटन स्टेट लो होगा, विच इज ऑटोमेटिकली गोइंग टू द एल्स स्टेटमेंट, कि अगर हाई नहीं है तो डेफिनेटली लो होगा वो, तो हम वहां क्या कर देंगे कि एलईडी पिन को विच इज 2 लो कर देंगे, राइट?
So let's call it out together.
Okay. Okay, I think we don't have much time. You guys, we will share the code with you guys. You can just code it out because we have a lot. Okay, you guys can continue with this for now. Now moving on to a very essential part, the sensor part. So we have a potentiometer with us. So it is like a regulator. Like हम फैन की जो स्पीड होती है वो हम कम कर सकते हैं या बढ़ा सकते हैं, राइट? सो ऐसे ही a potentiometer can be used as a regulator, right? So Zaid will be getting you with the theory of potentiometer.
Do you guys know what a potentiometer is? Can anyone tell me? Just write it in the chat box. Yes. Yeah.
Okay.
Can you just tell me what a potentiometer is?
People who love physics might know. Potentiometer.
Application of Wheatstone bridge. Right.
Nice.
Yeah. So let me tell you, potentiometer is just a variable resistor. So जैसे to measure potential difference between 2 points. ठीक है.
Okay.
Okay, right. So potentiometer just like a variable resistor in simple words. तो अगर आप इस knob को आप turn करेंगे, तो you will get a continuous value of resistance, right? Let's move on. So yeah. So this is the potential resistance strip. ये carbon की strip होती है. Where there are 3 terminals in this. So ये जो wiper है, जो आप देख सकते हैं, इसे आप जिस भी टर्मिनल के अंदर रखेंगे, वो उतने पार्ट का रेजिस्टेंस आपको अवेलेबल हो जाएगा. So these two extreme terminals are for ground and plus 5 volt, and this middle terminal is for analog input, analog reading actually. Yeah.
Okay, so since the potentiometer is used for analog reading, so we will be using analog pins here with us. So as you guys already told that there are 6 analog pins starting from A0 to A5. So this time we will be using analog pins. So can anybody guess like what can be the difference in the code when we are using analog pins instead of digital pins? Okay, do you guys know the difference between analog and digital?
Digital works on the principle of 1 and 0, and
Digital works on principle 1 and 0.
Okay, great.
Anybody else?
Anyone else? Analog कोई बता सकता है? Example तो आप लोग के सामने ही है यहाँ पे. Okay, nice. Let's move on. So analog is basically, okay, we have an answer.
Complete AC nature.
Analog is sinusoidal. Okay.
Right.
Great. Okay, you can also see here a sinusoidal wave. So analog basically takes multiple values, right? The analog signals can take multiple values, while the digital can only take, as Sanu told, values from 0 or 1 or high or low, right? So this is the difference between analog and a digital signal.
Okay, so moving on. Yeah, so we'll be using the analog pins for reading, है ना? तो analog pins क्या करता है कि it will be reading voltage values basically. वो आपके analog values को read नहीं करता, voltage की values को read करता है. तो since if already told कि 0 से 5 volt के बीच में range होती है हमारी Arduino की, so it will be reading a voltage from 0 to 5 volts, है ना? So फिर internally what happens is it will convert that 0 to 5 volts to 0 to 1023. ये एक arbitrary number है which was taken considering the framework of the Arduino board. तो क्या करता है कि 0 को 0 पे मैप कर देगा, 5 वोल्ट को 1023 पे मैप कर देगा अकॉर्डिंगली, है ना? तो जो बीच के इन बिटवीन जितने भी वैल्यूज है, लाइक फॉर एग्जांपल इफ यू टेक 2, इट विल बी मैप टू अ वैल्यू 409 एंड अकॉर्डिंगली सारे वैल्यूज ऐसे मैप हो जाएंगे. सो या, सो नोट इज एनालॉग इनपुट पिंस रीड लेवल्स फ्रॉम 0 to 5 volt and convert them to a range of 0 to 1023. If anyone is not following up till now, you guys can tell us.
Okay. Okay, let's move on. So when you download Arduino Ide, you can also see this part where you know about the serial monitor. Serial monitor is basically we upload our code to the Arduino, right? So when we want to see the command or when we want to display whatever is happening with the board, we use this thing called the serial monitor. It gives us the values if we are using something which has values in it, or here in the blink one we might know when it is on or when it is off, high or low that we have passed. So
0 to 5 directly to an extent of 1023. Yeah, it's coded internally. So what happens is जो भी आप वैल्यू देंगे 0 से 5 वोल्ट के बीच में, वो अपने आप it will map to 1023 के बीच में एक वैल्यू. So it's coded internally. आपको कुछ you don't have to do anything specifically.
Okay, we can take all the questions at the end. Okay, then I've told you about serial monitor part. So this is basically the output of the serial monitor. You can also see at the bottom corner, it's written baud rate, right? So do you guys have any idea like what it is, why it is 9600 set? Okay, you guys can type. Okay, let's take this example. If we are standing like this in front of each other and I am throwing one ball at a time, right? You will be able to catch the ball easily. But what if I'm throwing 10 balls at a time at you? I don't think so anyone would be able to catch all 10 balls at the same time. Okay. So what happens is we have to create a clear or successful, to create a successful communication between us, we have to set the rate at which I am throwing the balls at you or at which you will catch the balls, right? So we use this part to have a successful communication between the Arduino board and the laptop or the PC that you're using. We set this baud rate equal like 9600 here, and there are more options. You can just drop down and see in the view menu. And then in the code part, we write in the setup, we write serial.begin. It's where the communication is starting, 9600. So there the serial communication wala baud rate, and here जो हम कोड में लिख रहे हैं ये बिल्कुल सेम होना चाहिए. अगर ये डिफरेंट होंगे तो 10 बॉल्स वाला केस हो जाएगा, कोई कम्युनिकेशन बिल्ट इन नहीं हो पाएगा, इसलिए हमें ये सेम चाहिए, राइट? देन हमारा सेंसर वैल्यू. ओके, so this is basically the potentiometer code that we can share it with you and you can just try it on using Tinkercad. तो हम potentiometer के कोड के लिए क्या करते हैं, हम सबसे पहले अपना सेंसर को अपने पोटेंशियोमीटर की पिन को एक वेरिएबल में सेव कर लेते हैं. हियर आई हैव यूज्ड सेंसर वैल्यू. यू कैन यूज एनी वेरिएबल दैट यू लाइक. एंड सिंस क्योंकि हमने वहां पे एक एनालॉग पिन को कनेक्ट किया था, तो हम इस बार डिजिटल रीड की जगह एनालॉग रीड लिख रहे हैं. यहाँ पे हमारे कोड में डिफरेंस आ जाता है, डिजिटल की जगह सिर्फ एनालॉग आ जाता है और वहां पे हम पिन नंबर दे देते हैं जो भी हमें यूज करनी है. सो व्हाट डू यू गाइस थिंक, ये कहाँ पे जाएगा? लूप में जाएगा या सेटअप में जाएगा? ये वाला पार्ट, सेंसर वैल्यू वाला पार्ट आपका लूप में जाएगा या सेटअप में जाएगा? यहाँ पे हमने सिर्फ पोटेंशियोमीटर को डिफाइन करने के लिए उसके एक वैल्यू को स्टोर किया है और उसको रीड करा दिया है पिन में. Setup. Great. I think you guys are doing great. Okay. Set up. Okay. It's analog read. Analog read, guys. Okay. I think most of you got confused. It's saying sensor value, which is a variable, is stored. Analog pins is stored. And we have written analog read. So when we were writing analog, digital read and digital write, where we were writing? Were we defining it in the setup part or were we writing it in the loop part? जब हम digital read और write लिख रहे थे, तो क्या हम उसको loop में लिख रहे थे या फिर हम setup में लिख रहे थे? क्योंकि setup में तो सिर्फ एक चीज आती है, which is the pin, right? और loop में क्या आता था? जो हमारा main body of the होता था, code, right?
Functionality of the code, है ना?
Yeah. So anyone who wants to change the answer?
You're writing digital in the loop. No, right.
Great. Loop. Great. Now it's correct. So इसको remember करने के लिए you can just take note of this word called analog read or write or digital read or write. तो ये वाला पार्ट हमेशा आपका loop में जाएगा, ना कि setup में जाएगा. Okay? Okay. Great. Then to print the values, जहाँ पे हम programming में printf ऐसे sentences use करते हैं, यहाँ पे हम serial.println use करते हैं और वहाँ पे output की जो भी value होती है वो आ जाती है. मतलब यहाँ पे हम output pass करा रहे हैं. तो serial.println ताकि हमें कमांड विंडो में हमारा आउटपुट दिखे, इसलिए यूज होता है. देन मूविंग ऑन टू द कनेक्शन. अब हम यहाँ पे पूरा कनेक्शन नहीं करके दिखाएंगे. वी विल शेयर द पीपीटी विद यू. यू कैन जस्ट सी द कनेक्शंस. सो हियर वी हैव कनेक्टेड पोटेंशियोमीटर एंड एन एलईडी टुगेदर. सो पोटेंशियोमीटर बेसिकली यहाँ पे क्या करेगा, हमारा ये हमारे ब्लिंकिंग ऑफ द एलईडी को कंट्रोल कर सकता है. लाइक हम पोटेंशियोमीटर को मूव करेंगे तो हमारी एलईडी की ब्लिंक या तो तेज हो जाएगी, यानी मान लो 100% पे ब्लिंक कर रही है, तो हम उसको कंट्रोल कर सकते हैं 50% तक. मतलब पहले फुल पे ग्लो करी, पहले फुल पे ग्लो करिए, फिर कम पे ग्लो करेगी, राइट? So here we have connected these. So in the Tinkercad option, you also have this amazing option where you can also download, where you can also see the live examples. So I can share, yeah. Potentiometer वाला part के लिए.
Analog, yeah. So for the potentiometer part, you guys can type analog, and then you will see a bunch of options, right? You can see analog input, analog read serial, analog in and serial out. So select this analog in and serial out button option, sorry, and then you can drag it out. You guys can drag it out here. ठीक है, अब इसे डिलीट कर देते हैं. ये जो बाकी वाला हमारा सेटअप है. ओके, yeah. Okay, so yeah, so once this is complete, you guys can go to the code option and select, click on text, continue. Yeah, so you guys will already get the code here. जो इरफान ने समझाया वो सेम कोड है बिल्कुल. So let's just start the simulation. See.
Okay, so when Zahid is moving the potentiometer, आप देख सकते हो कि एलईडी का जो लाइट है वो कम हो रहा है और ज्यादा हो रहा है, यानी उसकी परसेंटेज बढ़ रही है और कम हो रही है. So this can be controlled using the potentiometer. This is one of the modification in it. So yeah.
Okay. So the next is PWM. Does anyone know what PWM actually is? Pulse width modulation. Yeah.
Great.
So as the name suggests, pulse width modulation. हम क्या कर रहे हैं कि we are controlling the width of the pulse. So using the controlling the width of the pulse से क्या होता है कि you can select for how much time a particular thing should be on or off, है ना? So these are the PWM pins. ये जो tilde sign आप देख सकते हैं in 3, 5, 6, 9, 10, 11. So this means these are PWM pins, right? In digital PWM pins.
Okay, so I think we have already discussed the code with you guys. Okay, so we have already shared this code with you. Then moving on.
So जैसा आपने देखा कि since ये जैसे हम जैसे हमने पोटेंशियोमीटर को हमने वैल्यू इंक्रीज करा, so it's increasing the brightness, and जैसे हमने डिक्रीज करा, so it's decreasing the brightness, है ना? So what is happening is the potentiometer is connected to analog input pin, the LED is connected to a digital PWM pin. So what is happening is this Arduino is reading the value from this resistor of this potentiometer from A0 pin and writing that value to the PWM9 pin, है ना? So how it's working is analog input takes a value of 0 to 1023, but PWM pins output a value from 0 to 255. So what we have to do is we have to convert that 0 to 0 and 1023 to 255. And in between values को हमें ऐसे ही scale down करना पड़ेगा accordingly. So for that scaling down option, we are using this map function. Map function क्या करता है कि it will take in 5 parameters. Namely, the first is the variable which you have to map. Where are you sharing the code? We will share the code in the classroom. जो आप जिससे connected हैं, we will share the code in the classroom. So the first is the variable value. Second pair is the maximum and the minimum, the maximum input values, and the next pair is output, the minimum and the maximum output values. So इस तरीके से we will be scaling down this range to this range.
Okay. Now, I think you guys have definitely heard the word motor in your houses, in the cars that we use, or like more of the daily life examples. So here we are using one such motor that can be connected to the Arduino, which is known as the servo motor. So what basically servo motor does is,
yeah, so what basically servo motor does is, servo motor is used for very precision controlling. So आप ये कह सकते हैं कि move 1 degree, so it will move the servo motor head to 1 degrees. So it's used for precision controlling of something else. So servo motor contains 3 pins. First, these 2 are the positive and the 5 volt and the ground pin. This pin is for analog input, analog reading, right? Analog output or analog reading. So moving on, this is our circuit. ये basic circuit है for controlling the servo motor. हम क्या करेंगे कि we will be connecting the red to the positive 5 volt, black to black to ground, and this will be connected to PWM 9 pin, which is used for analog input. Sorry, analog output here.
Okay, so this is the classroom code. You can just join the classroom if you want the code and all the stuff. Okay, so because programming is basically a good programmer, what he or she does is basically reduce the amount of lines in the code. So while we are incorporating servo motors in our code, we have this thing called a library of servo motor, which reduces our work from writing from scratch. So we are using this library called servo library to use the servo motor. तो हम उसको इनिशियलाइज अगर अपने कोड में कर देंगे तो हम बहुत सारे लाइंस ऑफ कोड से बच जाएंगे, राइट? सो दैट्स व्हाई बिफोर इनिशियलाइजिंग द सर्वो मोटर हम यहाँ पे एक लाइब्रेरी को इंक्लूड करते हैं, विच इज द सर्वो मोटर की लाइब्रेरी. तो इंक्लूड करने के लिए हम क्या लिखेंगे? सिंपली एट द स्टार्टिंग हम लिख देंगे #include और servo.h. इससे हमारी ये लाइब्रेरी ऑलरेडी आपके पास आ जाएगी. तो हमारे नंबर ऑफ लाइंस कम हो जाएंगी इन आवर कोड, राइट? सो देन मूविंग ऑन टू द कोड, हम क्या करते हैं, यहाँ पे एक ऑब्जेक्ट डिफाइन कर देते हैं अपना, विच इज सर्वो, एंड देन माई सर्वो, और सर्वो इज द आपका लाइब्रेरी जो हमने इंपोर्ट किया था अंदर. देन वी स्टोर इट इन एन ऑब्जेक्ट वेरिएबल कॉल्ड माई सर्वो. आप इसका नाम चेंज कर सकते हो, दैट्स अपॉन यू सिंस इट इज अ वेरिएबल. देन अगेन हम क्या करते हैं, यहाँ पे अपना जैसे हम पिन्स ऊपर डिफाइन कर रहे थे, यहाँ पे भी हम पिन्स डिफाइन करने के लिए क्या लिखेंगे, अपना जो हमने वेरिएबल नेम दिया था my servo dot attach and then the pin number that we are connecting to the servo motor, right? So pin number को आप attach वाले bracket में लिख देंगे. Then again हम यहाँ पे भी डिजिटल रीड और राइट वाला कॉन्सेप्ट यूज करके यहाँ पे डिजिटल रीड और राइट की जगह यूज करेंगे माई सर्वो, जो आपकी लाइब्रेरी है ऑलरेडी, माई सर्वो डॉट राइट, और वहां पे हमने एक पोजीशन नाम का वेरिएबल बना दिया है, उसको वहां पे सेव कर देंगे, राइट? इट इज एक्चुअली टेलिंग द सर्वो टू गो टू दिस वेरिएबल कॉल्ड पोजीशन, विच इज POS हियर. देन अगेन हमने यहाँ पे ऑलरेडी कोड को लिख रखा है, और Tinkercad पे भी you can use it using the same searching option.
So
Zara
let us show you. Let's stop the simulation first, and then what you can do is आप यहाँ पे servo select कर सकते हैं. Servo. Click on this servo and drag it out. Stop simulation. Yeah, and drag it out. So this is our same servo motor. हमने इसमें क्या करा है कि डिजिटल पिन 9 से कनेक्ट कर दिया है, that one pin, और बाकी दो को 5 and ground है ना. For seeing the code आप देख सकते हैं कि the code is the same which I told. So these are just another way of writing the code. या फिर you can go this way of writing my servo attach, or you can define it this way, right? And this is doing the same thing. It's using a for loop to define the position, for writing the position, and it's incrementing the position value by 1 degrees. So अब जितना भी आप यहाँ पे position value देंगे, it will correspond to 1 degree position. Like if you say 5, then it will correspond to 5 degrees. So let's run this program.
Okay, you can actually see it's moving clock and anti-clockwise both, because in the for loop we have given the initial value from 0 to 180, and then again from 180 to 0. So it was moving like this and then again this, right? Okay, so okay, then moving on to the next part is the most widely used sensor, the IR sensor. Can anybody tell me the full form of IR? IR sensor. IR किसके लिए stand करता है यहाँ पे?
Infrared.
You can just write it in the chat box. Infrared.
Okay, great. So IR sensor, nice. Okay, so infrared sensor क्या करता है? पहले तो इसकी भी 3 पिन्स होती हैं. One is the VCC जो कि 5 वोल्ट 3.3 वोल्ट से कनेक्ट कर सकते हैं. Then ground pin, then again आपकी आउटपुट पिन जो कि आपके Arduino के किसी भी एक पिन से कनेक्ट हो जाती है जाके. Then आपका जो ये IR सेंसर मैकेनिज्म काम करता है वो रिफ्लेक्शन के बेसिस पे काम करता है. तो यहाँ पे क्या होता है कि हमारे IR सेंसर में एक ट्रांसमीटर साइड होता है और एक रिसीवर साइड होता है. तो जैसे ही हमारा एमिटर जो होता है अपना इंफ्रारेड सेंसर, आपकी इंफ्रारेड वेव जो होती हैं वो एमिट करता है, और किसी भी ऑब्जेक्ट, लाइक मैंने कोई कोड लिखा, उसमें मैंने एक ऑब्जेक्ट डिफाइन कर दिया कि उससे टकराएगा, अब किसी भी ऑब्जेक्ट से टकराएगा वो, और उसके बाद क्या होगा, उसका जो वेव होगा वो रिफ्लेक्ट बैक हो जाएगी और वो जाएगी किसके पास, आपके आईआर सेंसर के रिसीवर के पास, राइट? सो इट इज एमिटिंग एंड देन रिसीविंग. सो दिस इज द मैकेनिज्म ऑफ आईआर सेंसर. तो यहाँ पे इसको हम ऑब्जेक्ट डिटेक्शन के लिए बहुत अच्छे से यूज कर सकते हैं, IR सेंसर. देन मूविंग ऑन टू द कोड पार्ट ऑफ द IR सेंसर. यहाँ पे भी हमने सबसे पहले इसका भी आप आराम से, इसमें भी डिजिटल कोई भी पिन डिफाइन कर दीजिए. देन अगेन यू हैव टू गिव आउट the loop part where we are also writing where something is present or not, वो उसी हिसाब से चलेगा. और डिजिटल पिन्स के लिए हम क्या करते हैं कि वो रिसीव करेगा और वो वापस आ जाएगा. इसके लिए हमने यहाँ पे लिख दिया है कि स्टॉप इफ समथिंग इज अहेड, मतलब उसके पास इतने डिस्टेंस में अगर कुछ रखा है 500 सेंटीमीटर के, तो हम उसको वापस बुला लें, वरना वो आगे चलता जाए.
So what happens is, जैसे if this infrared sensor detects something, so क्या होगा कि जैसे ही उस पे वापस वेव आई, so it will turn this pin on, हाई कर देगा उस पिन को. So इसलिए हम लोग यूज कर रहे हैं इस if स्टेटमेंट को. So if it's telling high, तो हम इसे प्रिंट करवा देंगे. If it's low, so हम path is clear ऐसा प्रिंट करवा सकते हैं. So we are storing it in a variable called has obstacle, and then we are checking if that has obstacle variable is high or if it's low.
Okay, great. So this is the infrared sensor that we have talked about. Okay, so this was all from our side. If you have any doubts or you want to ask anything related to this or the competition, you can definitely ask it out in the chat box or just unmute yourself. You can explore the Tinkercad library. It's really amazing to just get started with Arduino, because you can see different things happening in front of you. Okay. So we are open to questions if you have any.
Zahid bhai? Hello?
Yeah, Tahsin.
I was asking, जो लैंग्वेज हम लोग इस्तेमाल कर रहे हैं इसमें, वो सी लैंग्वेज इस्तेमाल कर सकते हैं ना, या फिर ये इस लैंग्वेज का नाम क्या है? ये आर्डिनो लैंग्वेज?
Yeah, it's a modified form of C language. Just a little modification from C. ये C ही है एक तरीके से, लेकिन another version बोल सकते हो of C.
Okay.
So we will be posting a project on the Google Classroom. या फिर अगर अभी बताना है, so we will be telling about that project too.
Okay, and if you have not registered for the workshop, you can just register for it now. We can share the link with you. Then only you can join the classroom if you haven't. Okay, if you guys have any questions, you can definitely ask.
Zahid bhai, as we know कि हम लोग जो सी लैंग्वेज को बेसिक से स्टार्ट करते हैं किसी भी कोडिंग के लिए, तो आर्डिनो को सीखने के लिए हमें कहाँ से स्टार्ट करना चाहिए? मींस फ्रॉम बेसिक्स, बिकॉज आई एम फ्रॉम फर्स्ट सेमेस्टर.
Yeah, so for Arduino को सीखने के लिए you should have a basic knowledge of C language. So मैं definitely recommend ये करूँगा कि have a basic knowledge of C and then start with Arduino. क्योंकि जो for loop है, if loop है, those are all parts of C language. So
yeah, we understood.
Please give a brief about the competition. So competition, it's not a competition, it's actually a project. So होगा ये कि we will be posting a project, a question, a problem statement. A problem statement on Google Classroom. So आपको ये करना पड़ेगा कि you will have to code it out in Tinkercad and then download that project, या फिर आप you can just give us the link of the Tinkercad to us and then we will be evaluating it accordingly.
We will be giving all the details in classroom. If you haven't registered, just register for it now and you will get all the details.
Any last date for what?
For the submission, I think.
To submit. We'll be giving around 2 to 3 days. मतलब ज़्यादा बड़ा project नहीं होगा. It's just a basic project to code it out. मतलब जो भी whichever information you need, you will find it in the Google Classroom when you post the project, and you will get approx 2 to 3 days.
The competition date is 6th March. So yeah, you have time till then.
So 4 days. No, 4 days. No, 6 days. Yeah, up to a week.
Okay, I think you guys don't have any questions. You can definitely email us if you have any queries or just post things in the classroom and we will respond it definitely.
If you guys have any queries, then you can ask or we will be closing the session.
I think.
हेलो
या तहसीन.
साहिद भाई, जैसे कि सी लैंग्वेज को प्रैक्टिस करने के लिए हम लोग जो विजुअल स्टूडियो को इस्तेमाल करते हैं आईडी की तरह, तो क्या हम लोग आर्डिनो की इस्तेमाल मतलब कि प्रैक्टिस करने के लिए कोई एनी एप्लीकेशन और सॉफ्टवेयर समथिंग लाइक दैट?
या यू कैन यूज जो हमने दिखाया था टिंकरकैड, यू कैन यूज टिंकरकैड और
ये तो ऑनलाइन हो
यूज आर्डिनो आईडी. मतलब यू शुड हैव एन आर्डिनो बोर्ड एट होम ताकि आप लोग ट्राई कर सकें, वरना यू कैन यूज द टिंकरकैड सिंपली.
ओके.